Okay, here we are once again using one trig ratio in order to find the other 5. What's different here is that we're using the sign of a trig ratio to determine the sign of the remaining trig ratios. So we're told that the secant of the angle is radical 3, and we're also told that the tangent is negative. So let's think about that. In the coordinate plane, we know that all of them are positive in quadrant 1. All advanced students take calculus. So all of them are positive in quadrant 1, so I know my angle isn't in this quadrant. My secant is positive, so it's the same as the cosine, so it's got to be in this quadrant. And in this quadrant, the tangent will also be negative there, so we're good. We know where our angle is going to be. So now, we know that the angle is here, which means that the x-coordinate is positive, but the y-coordinate is negative. So here's my theta, and I know that the secant is radical 3, and the secant is the hypotenuse over the adjacent, so that means this is radical 3, and my adjacent side is 1, and we're going to use Pythagorean's theorem to find this remaining length of the triangle, which is my y-coordinate. So 1 squared plus y squared equals radical 3 squared. And when we multiply that out, we get that y squared is 2. And because of where this point is, we realize that the value that we're actually interested in is negative radical 2. And so now we have all of the information that we need in order to plug into the sine, cosine, so on and so forth. The sine of theta, remember, is y over r, so that's negative radical 2 over radical 3. We rationalize the denominator and get negative radical 6 over 3. Cosine is just the reciprocal of the secant, which was given to us, so that's going to be 1 over radical 3. Again, we rationalize the denominator and get radical 3 over 3. The tangent of theta is opposite over adjacent, so that's negative radical 2 over 1, so just negative radical 2. The cosecant is the reciprocal of the sine, so that's negative radical 3 over radical 2. Rationalize that, and hopefully by now you don't need to see every single step of the rationalizing process, and you'll realize that that's negative radical 6 over 2. We already know the secant, the cotangent, is the reciprocal of the tangent, so that's negative 1 over radical 2, and that will simplify to negative radical 2 over 2. And you may want to pause a moment to get everything from this screen that you need, because I need to erase in order to have room to do part B. I'm sorry that I didn't give you enough space on your notes. In part B, we start the same way. I know that the cotangent is positive, and I also naturally know that the sine is positive because I see it. So again, let's consider advanced students taking calculus. I know that the sine is positive, and I know that the tangent is positive. So since I want both of those to be positive, my angle is going to be in the first quadrant, where everything is positive. So hopefully that helps make things a little bit easier. In addition, my triangle would have 5 at the side opposite theta, 7 at the hypotenuse, and I would use Pythagorean's theorem to find this length. And since in the last example I kept the radical, I'm going to do the same here. So 5 squared plus y squared equals 49. I'm getting ahead of myself, sorry. 7 squared. Hope you were with me there anyway. So 49 minus the 25 is going to be 24 equal to y squared. So y is the square root of 24, and let's go ahead and simplify radicals because by now you should be able to. 24 is divisible by 4, which is a perfect square. So my y is 2 radical 6. So I already know my sine. My cosine is that adjacent side I just found over the hypotenuse. Tangent is opposite over adjacent, so that's 5 over 2 radical 6. Rationalizing my denominator, I get 5 radical 6 over 12. Cosecant is the reciprocal of sine, so that's 7/5. Secant is the reciprocal of the cosine, so that's 7 over 2 radical 6, and when I rationalize that denominator, I get 7 radical 6 over 12. And then finally, the cotangent is the reciprocal of the tangent, but again, I'm going to take the reciprocal of the easiest fraction possible, which would be this one. So that's 2 radical 6 over 5. This unit circle, and it is on your reference sheet, this unit circle will help you find the sine, cosine, and tangent of angles, I hope, a whole lot easier now. Notice that in the unit circle, we consider the sine of t. I was kind of using this ahead of time, so I apologize for that. But the sine of t is the y-coordinate over r, and since in the unit circle my r is just 1, it's y over 1, so just y, and then the rest of it you see there. And so any point can be expressed as the cosine of the angle, comma, the sine of the angle. So we're using the unit circle to find the exact value of each expression. So cosine of pi over 4, I'm looking at my reference sheet, and I know that cosine of pi over 4 is going to equal, well, I'm looking at my reference sheet, and at pi over 4, my x-coordinate is radical 2 over 2. So that's my answer. Use the reference sheet. It'll make things very, very easy for you. That's part A. Part B, the sine of 120. According to this screen, the sine of an angle is basically my y-coordinate. So looking at my unit circle, I see that at 120 degrees, my y-coordinate is radical 3 over 2. So the sine of 120 is radical 3 over 2. The cotangent of 210, back here, it says cotangent is going to be x over y. So I look at 210 on my reference sheet unit circle, and my x-coordinate is negative radical 3 over 2, and my y-coordinate is negative 1/2. So instead of dividing this by negative 1/2, I'm going to multiply by negative 2 over 1. My negatives cancel out and my 2's cancel out, and that's just radical 3. Finally, part D, secant of 7 pi over 4, that's going to equal, well, what does the secant equal? It's 1 over my x-coordinate. And at 7 pi over 4, my x-coordinate is radical 2 over 2. So basically I'm taking the reciprocal of that x-coordinate. So it's 2 over radical 2. But I would, of course, simplify that or rationalize the denominator. So when I do, I get 2 radical 2 over 2, which is just radical 2. So hopefully you're seeing that this reference sheet, while you may have initially looked at it and grown panicked by how much was in that unit circle, how much is in that unit circle ends up being tremendously helpful to you. So in this last example, we're kind of getting ready to start graphing these trigonometric functions. And what we want you to notice is that if we take the number line and wrap it around a circle, then the angle is my input value, my x, and my y kind of repeats itself over and over again. And you'll see that I'm telling you that it repeats itself every 2 pi for sine or cosine functions, and it repeats itself every pi for tangent functions. So what that means is if I'm asking for the sine of 13 pi over 4, well, you don't see 13 pi over 4 on your reference sheet unit circle. But 13 pi over 4 is equivalent to, because it is also coterminal to, the angle that I get when I subtract 2 pi away from 13 pi over 4. So if I take 13 pi over 4 and I subtract 2 pi from it, 2 pi is equivalent to 8 pi over 4, then what I'm actually wanting to find is the sine of 5 pi over 4. And on my unit circle, that's just going to be the y-coordinate at 5 pi over 4. So I'm looking at my reference sheet and I find 5 pi over 4, and the y-coordinate at 5 pi over 4 is negative radical 2 over 2. So that's my answer. Similar idea in part B. This time they gave us a negative angle, so instead of subtracting 2 pi from that, I'm going to add 2 pi to that. So negative 4 pi over 3 plus 2 pi, which is equivalent to 6 pi over 3. And what I'm actually trying to find now is the cosine of 2 pi over 3. And the cosine is just going to be the x-coordinate at 2 pi over 3 on my unit circle. So 2 pi over 3 on my unit circle has an x-coordinate of negative 1/2. That, therefore, is my answer. Because the period of a tangent function is 1 pi, I'm just going to subtract 1 pi away from this until I find a value that is on my reference sheet. So 15 pi over 6 minus 6 pi over 6, because that's equivalent to 1 pi, gives me 9 pi over 6, which is equivalent to 3 pi over 2. And that is an angle on my reference sheet that is actually 270 degrees. So the tangent of an angle, remember, in the coordinate plane is y over x. So that's negative 1 over 0, that's undefined.